Unfortunately, 1/3 of that nourishment never makes it to anyone's plate. In wasting this food, we're also unnecessarily consuming about 1/4 of the water used in agriculture, as well as 3 billion barrels of oil annually. On the flip side, the bowls of an estimated 1 billion people still go empty. Our food waste could feed those 1 out of 7 hungry people on the planet. Eliminating this hunger is essential for their long-term human development. Fresh food can be amazingly tasty and diverse in its appearance and variety. However, there is little monitoring for contamination or mishandling in local food markets. And more importantly, local food supplies are easy to disrupt, either by nature or through the course of human events. And indeed, with climate change, we expect that the rate of those disruptions and their severity will grow. So the problem we have currently is not so much a lack of food, but a lack of food where it is really needed. Modern food supply chains can span continents. Unfortunately, the tools to manage that supply chain have not kept pace. Typically, food is disposed of simply based on arbitrary disposal dates, expiration dates, or on extraordinarily high levels of appearance. If we had accurate knowledge of freshness, we could avoid using energy to send food to landfills. We would send it instead to really where it is needed. Also, by not having that food go to landfills, we would avoid the greenhouse gases that are produced when the food is consumed. We all know to err on the side of caution in terms of food safety. In 2011, the CDC reported that 1 in 6 Americans fell ill because of food poisoning. This resulted in 128,000 hospitalizations and over 3,000 deaths. So it's really important to answer correctly, is our food safe to eat? Even apparently fresh food can harbor pathogens. This very fresh-looking piece of cantaloupe can have lurking inside bacteria such as Listeria, which can cause serious illness. Of course, the techniques of traditional microbiology can tell us the answer of if our food is safe to eat. However, these techniques require days to give us the answer. Additionally, these techniques require costly specialized labs and trained technicians. If instead we could imagine a food sensor that was as simple, cost-effective, and rapid to use as a piece of litmus paper. Instead of measuring acidity, this test would tell us, is our food safe to eat? Nature has given us antibodies which are specific for pathogens, and we can use those antibodies to create this food sensor on a piece of paper. In this picture, the antibodies, the Y-shaped molecules, are shown to float freely in solution. However, for a diagnostic test, they would be affixed to a surface. The larger the surface area, the greater the sensitivity of the test. And that's why in my lab we use paper-based substrates, because all the surfaces of the fiber give us higher sensitivity because of the increased surface area. The green fluorescence that you see here represents the successful attachment of the antibodies to these essentially pieces of paper. So now we have the first component down. And now what we create is a lock and key mechanism where the antibody only works for a specific pathogen. And the yellow fluorescence that you see here is evidence of that successful lock and key mechanism. We can do this type of processing on roll-to-roll machinery, which is analogous to traditional printing. And we can also convert that biochemical reaction into an electrical signal, basically a change in electrical resistivity that we can read out by many devices, including a mobile cell phone. To do so, we simply coat the paper with electrically conducting polymer before we attach the biological components. So our goal is to create a food security index that's universally verdant across the globe. And the questions that I will hope to discuss with some of you are, what types of sensors would bring the most benefit, and how should those sensors work in combinations with other technologies, such as mobile devices and big data, to radically slash food waste in